All right, guys, so which is greater, the square root of 64 or the cubed root of 64? So what is the square root of 64? It is 8, because we take the square root, we're saying what number times itself. And 8 times 8 would give us 64. Now what is the cubed root of 64? It is indeed 4, because 4 times 4 is 16, and 16 times 4 is 64. So the square root of 64 is bigger than the cubed root. Because whenever we get a bigger root of a number, we're trying to see what number times itself that many times is the number inside the radical. So anytime we increase the index, what our root is, the smaller the number is going to get. There is only one exception for that, and that is taking, say, the square root of 1, which is 1. The cubed root of 1 is the 1,000th root of 1 is, well, 1. The only exception is 1. Yes. Yeah, because it just works out that anytime we multiply 1 by itself, we still get 1. Previously, you've learned that the nth root of a can be represented as this here. So the nth root of a is the same as a to the 1 over n. Now, in a general sense, what we can say is the nth root of a to the x is equal to a to the x over n. The nth root of a to the x is equal to a to the x over n. For any real number and integer n greater than 1. This is true. And this here is actually quite a nice explanation, and this works out very nicely, because if we think about stuff we've done before, so if we said the square root of a squared, well, we've just said that this is just a, because a square root and square cancel each other out. And we didn't talk too much into this. Now, if we use what we just saw here, the nth root of a to the x is equal to a to the x over n. For our problem here, well, we have a, and our fractional exponent, the exponent inside goes on top, and our root goes on bottom. Well, 2 divided by 2 is 1. And this is why we can say the square root of a squared, or vice versa, the square root of a, parentheses squared, is just a. They simplify out. This is why this works, because of our fractional exponents and the way they work here. So if we look at these here are going to be the exact same. Because if we talk about the square root of 9, well, the square root of 9 is what? 3. 9 to the 1/2, if we just plug that into a calculator, it is also 3. Square root of 2. Clear all that out. So if we go second square root 2, it does give us the square root of 2. Or if we approximate it, we get this decimal here. Now we can do 2 to the 1/2. And see that we get the exact same decimal. They are the same. So these here are indeed the exact same. And we can also look at the cubed root of 8 in our 30xs. We can do 3 second root 8. And we get 2. Now we could have done our second nth root, but we have to change it from a and s to 3. 8 on the inside, and we get 2. The cubed root of 8 is 2. Now if we say 8 to the 1/3 power, we get 2 as well. So these are both 2. They are the exact same answer. Now if we wanted to do this in the graphing calculator, now the graphing calculator does not give us an x root as the 30xs does for a straight key. But if we hit math, the fourth one down is the cubed root. The fifth one down is the nth root. So if we did the nth root, I can just fill a number in and do 8. Or we can say 8 to the 1 divided by 3. We get the exact same thing. Questions on this so far? So we're seeing that now we also can evaluate these here, and we work from the inside out. So we would take, if we were doing this part by part, we would first take the square root of 5 and then cube it. So in the 30xs, we can take, here we can say parentheses, second square root of 5 to the 3rd. And we get 11.18033 if we're using a calculator to approximate this. Questions on this so far? Now, for some of these, especially on the ACT where they ask you to evaluate problems like this here, we could do it by hand and try to work it that way, or we can see what this is and check the answers to it. So we can take each of the answer choices and approximate them as decimals and see which one matches up. But if we did this by hand, the square root of 5 is the same as our fractional exponent. The 2 would go on bottom and the 1 would go on top. The square root of 5 is same as 5 to the 1/2 to the 3rd. Powers of powers multiply. So we can say the same as 5 to the 3/2. And again, this is using some manipulation of the numbers. 5 cubed is 125 to the 1/2. But again, this is more manipulating the numbers to get there. And if we looked at a calculator and said 125 to the 1/2, we get the exact same number. So this here is the approximation of this, and if we reduced it a little bit here. Let's look at the next one, the 4th root of 4 squared. Well, the 4th root of 4 is not 1. Because if we wanted to look at the 4th root of 4, we will see that it's 1.1 or 1.4142 going on here. If we wanted to type the whole thing in, we could say parentheses 4th root of 4 squared. And the 4th root of 4 squared is 2. Now this seems like an odd thing to come out of this, but if we break this down and work with it, we will see how this works. Now if I rewrite the fourth root of 4 as a fractional exponent, well, the exponent inside, or the exponent inside the radical is 1. The root, what goes underneath the exponent, is 4. So we're looking at 4 to the 1/4. But again, powers of powers multiply. So what is 2 times 1/4? So we're looking at 4 to the 1/2. The 1/2 exponent is the same as the square root. Our index would be 2. The power of with 4 is 1. And the square root of 4 is 2. Now we don't necessarily need to write the 2 for square roots. It's understood, but we can if we want to. Questions on this here? Now we can look at the next one, the cubed root of 9 squared. So when you say parentheses, math, and we can select the cubed root of 9, close parentheses, squared. And see what we get. So if we were looking for a decimal approximation, we would get this here. Now, if we wanted to write this in rational form, well, the cubed root of 9 is the same as 9 to the 1/3. Now we can multiply our exponents and get 9 to the 2/3, and this would be the same as what we have here. Because sometimes these will simplify and be nice numbers, and sometimes they will not. Because this will not reduce to a nice number. And we have this here. Because 9 to the 2/3 is the same as 4.326. And we say 9 to the 2/3, and we get the exact same thing. Questions on any of this here? Next one we have is the 5th root of 10 to the 4th. So we do parentheses, 5 math with a graphing calculator. And we go down to the 5th option, 10. Fifth root of 10 to the 4th. We get this here, 6.30957. And going on. Now if we did this in the other calculator, we did parentheses 5, 2nd root of 10 to the 4th. And you see we get the exact same thing. Now the other way we could have typed this in is we could have rewritten our radical as a fractional exponent. Now the exponent with the 10 or exponent inside is 1. Our root is 5. And powers of powers multiply, and 1/5 times 4 is going to be 4/5. And in either calculator, we can do 10 to the 4 divided by 5 and get 6.3095. Any questions on this here? Now, does it make sense for these here, 9 to the 2/3 and 10 to the 4/5, to give us a number smaller than the number we started with? So 9 to the 2/3, if we apply the 2/3 exponent or 4/5 exponent, does it make sense, or is it reasonable to say that the number we finish with is smaller than the number we started with? Because what is 9 to the first? Is 9. Anything to the first power is the number itself, yes? And if we square something, 9 squared is what? 81. Because we're saying we're taking the number, multiplying it by itself, yes? A whole number of times. So if we said 2/3, are we getting bigger or smaller? Smaller. 2/3 is smaller, yes? Because 9 to the first should give us 9. So 9 to the 2/3 should be smaller than it. Because if we said 9 to the 1/2, we're wanting what? What times itself is 9? Half. Half. Now, it's not specifically half, because half of 9 is 4.5, because the number times itself. We're reducing it by a power of 1/2. Questions on any of these here? Now, we're going to move on to these here. 8 to the 2/3. Eight to the 2/3. Now the division of 3, the bottom 3 is saying that we're taking a cubed root. We're wanting to see what times itself 3 times gives us 8. Because if we're doing this by hand, we can look at it as 8 to the 1/3 squared. Because we can split those up. 1/3 times 2, or 1/3 to the second, is the same as 2/3. Because 2 times 1/3 is 2/3. So 8 to the 1/3 is really just saying that we have what? The cubed root of 8. Now what times itself 3 times is 8? 2. Because we can do a factor tree, which would be 2 times 4. 4 is 2 times 2. So we have 3 2's. So the cubed root of 8 is 2. 2 squared is 4. So 8 to the 2/3 is 4. In a calculator, we could do 8 to the 2/3 and get 4 as well. We could have also said 8 to the 2/3 and gotten 4. Now the next one we're going to look at is 6 to the 5/2. Some of these are nice. Now 6 to the 5 halves. All right, guys. So we could say this is the same as 6 to the 1/2 to the 5th, because the 1/2 is our root. So we're saying we're taking the square root of 6 to the 5th power. Can we take the square root of 6 nicely? No. So we could say parentheses second square root of 6 to the 5th. You can get 88.1816, this number here. Or we could have said 6 to the 5 halves and gotten the exact same thing. Questions on any of these here so far? And again, these are different ways we can look at these powers and exponents. All right, we're going to skip those next two and look at these two here. Evaluate each expression without using a calculator. So, if we're going to do this without a calculator, again, what we were doing is going to be essential, what we were doing on the last few, because we're saying 4 to the 3 halves. We can put the 3 on the outside, and our fraction on the inside is going to be 1/2. So we have 4 to the 1/2 to the 3rd. Well, what is 4 to the 1/2? Because the 1/2 is saying the square root of 4, which is indeed 2. And what is 2 cubed? Because 2 times 2, 2 squared is 4. And if we multiply by 2 again, we get 8. So 4 to the 3 halves is 8. Now, does it make sense that 4 to the 3 halves, our result was bigger than what we started with? Because what is our exponent? Our original exponent. Is that bigger or smaller than 1? So should we expect the number to get bigger? So our next one, 32 to the 4/5. Is this number going to get bigger or smaller? Smaller. Now what we can look at this is 32. We put 4 outside, and our number inside is going to be 1/5. Because 4/5, we can break it up to 1/5 and 4. Now 1/5 is the same as saying what? The 5th root. Because the number on top, the 1, is our exponent attached to 32. And the number on bottom is our root. So our 5th root of 32. So we're trying to see what number times itself 5 times gives us 32. So we can do factor tree, because 2 would be 2 and 16. 16 is 2 and 8. 8 is 2 and 2 and 2. And how many 2's do we have? 5. So the 5th root of 32 is 2. And 2 to the 4th would be what? So the 32 to the 4/5 is 16. Questions on this here? Let's look at the next two. 625 to the 3/4. Should this number get bigger or smaller?
It's small. Does that say without a calculator? Oh, no. When?
625 to the 3/4 is?
125. Whatever it is. My brain looked at the board. My brain's not even working today. Clinton, you weren't really careful this morning. Okay, You're the one who slept.
Let's look at the next one. 49 to the 3/2.
Big.
It's going to get bigger. Yeah.
340. Oh, yeah, 343.
Because if we split this up, because 7 to the 1/2, or 49 to the 1/2 is 7.
Yeah.
7 cubed. Well, we know 7 squared is what?
49.
So we need to multiply 49 by?
If it's 343, I'm doing that at all, y'all.
7 times 4 is 28, plus 6 is?
Oh! But it's because I cheated, so it doesn't matter. I was right. All y'all down.
Now we could write this in as 49 to the 1.5.
Okay.
Because 3/2 is what is a decimal? 1.5. Questions on this here? Real nth roots of a. Real nth roots. So if we're given a value of a, and the root we're taking, as long as the root is greater than 1, we're going to have one of these set of setups. Now let's look at if we take an odd root first. If we take the odd root of a value greater than 0, so we take the odd root of a positive number, then the nth root of that will give us one real root. And it's just going to be whatever a to the 1 over that root is. Now if we take the odd root of 0, we get one real root. It actually works out to be 0. Now if we take the odd root of a value of a less than 0, a negative number, we get one real root. And it's just whatever that root of that number is. For 0, it's going to be equal to 0. But with odd roots, we have one root. No matter what the number is, inside the root, we have one solution. Whenever we take the odd root of a positive, 0, or negative number, we have one. Even roots. If we take, so a less than 0. I had those flipped. A less than 0, so negative numbers. We have no real nth roots because we can't take the even root of a negative number and get a real root. Now, if we take the even root of 0, we get one real root, and that root is 0. Now, if we take the even root of a positive number, we get two real roots. So we have to add the plus or minus in front of it. So the only one that we really have to pay attention to is if it's an even root and the number inside is positive. So let's look at these here. Find the indicated real nth roots of a. And this here we're dealing with nth root of a. Now our first one here, we can set this up. Our nth root is 3 and the value of a is negative 216. Now since we have an we have an odd root, how many solutions should we have? One. Because looking at the previous one, if it's an odd real root, we have one real root, or one real root.
Wow. So, one real root.
And it's going to be?
One real root.
No, what is the actual answer? So we need to plug it in. So we can do 3 And it is.
You know that. Oh.
Let's look at the next one. So our n in this case is 4, and the a value is. Now, since we're taking the even root of a positive number, how many solutions should we have? 2. So we have to add the plus or minus. Now here we can do 4 root. So the fourth root of 81 is 3. Positive or negative 3. So we can write plus or minus 3 instead of writing 3 comma negative 3. Questions on this here? Let's look at the next one. N is 4, A is 16. So we're looking at the fourth root of 16. And what would the fourth root of 16 be? Almost. So we have an even root plus or minus 2. And we could check this here because we could say negative 2 to the fourth power is positive 16. And 2 to the fourth power is also positive 16. Now, if we look at the previous one, because negative 216 to the third, cubed root of negative 216 was negative 6. So if we go the other way, and we say negative 6 to the third is negative 216, yes? We can see that here. Now, what is positive 6 to the third power going to be? It is a negative times a negative is a, and if we multiply it by one more negative, we get back to a negative. So this property of negatives that we get, that's why we can take the odd root of a negative, but not an even. So number 2. So our n is 2. We don't necessarily have to write it in because it's understood. And the number inside this time will be?
So when we put the 2 in, wouldn't that just be 1?
Or
They cancel each other out.
we don't have to write it in because it's understood. Because when we say a square root, or we write it without the 2, here, it's understood to be a square root. It's understood to be there. Just like if we have a here, it's to the first power. It's just one of those that's been accepted. So even root of a negative, no real nth root. Because again, it wants us to find the real nth root. Because there is a root for it. Because the square root of 49 is 7, but the negative comes out as I. Because the square root of negative 49 is negative 7i, but is not a real root. No real root. Questions on any of this here? Questions on any of this here? And that's it. That's it.